Now today we're talking about isotopes. With isotopes, we know that, with any of our atoms, we have protons, neutrons, and electrons. And protons, of course, determine what element it is. And, protons can't change. We have where there's changes in neutrons, which are known as isotopes. And we'll talk more about ions. Well, you kind of saw ions in the notes that you took, but ions is when there's a change in electrons. And we will come back to ions later on. So we're talking about isotopes. We know that the definition of an isotope is that it is pretty much the same element, but different number of neutrons. So therefore, if it's the same element, same number of protons, but different number of neutrons. And since it's a different number of neutrons, we know that the atomic mass is made up of the protons and neutrons. So that would make sense. Therefore, it's also a different atomic mass. Now, the isotope notation is just the element symbol and the atomic mass, literally with that dash in the middle and the atomic mass. So looking at some examples of isotopes, if we're looking at this first one where we have hydrogen, that's what that H is, and the atomic mass for hydrogen is approximately 1. It's like 1 point something. And you'll have to be pulling up your periodic table on your own so that you can see the masses of these things. But it also tells us the mass right here. So the star by it kind of signifies that it's the original 1. So the atomic mass is 1. The number of protons, of course, is 1 because it's hydrogen. We can really do that for all of these. The number of electrons, since we're talking about pretty standard ones, we're not talking about ions, so the number of electrons is the same. Now, the number of neutrons, even if I was not sure of the number of neutrons, I know that the mass is 1. So therefore, the mass minus the number of protons will tell me my number of neutrons. So 1 minus 1, this one has 0 neutrons. Now this one, look at the next one. My atomic mass is 2. My number of neutrons, 2 minus 1. Now I have 1 neutron. And you can kind of look ahead. Go ahead if you kind of got it, and check it. So then you can pause this video. I'm pretty sure you can too. So then you have 3. This is hydrogen 3. So my atomic mass is 3, and it has 2 neutrons. Easy enough. So looking at this next one, we have C12, which is carbon 12. So if I'm looking at the atomic mass for this, it is 12. My number of protons for carbon is 6. It is number 6 on the periodic table. Therefore, I have 6 electrons. 12 minus 6, it is 6. Next one, I have carbon 13. I have 13, 6. It's going to be 6 for all of them, for all of these, all the protons and neutrons. The only thing that's different is my number of neutrons. So now I have 7. Looking here, now I have carbon 14. So my mass is 14, 6 protons, 6 electrons, and that means I have 8 neutrons. All right, moving on. So if we are identifying isotopes, we're trying to figure, when it says, how do you determine the name of an element? Well, of course, it's the number of protons. Not like how the specific name has come about. We're just saying, like, when we're naming them, it's the number of protons. It's always going to tell us what element it is. How do you determine the atomic mass of an isotope? You should know that by now. It is the neutrons plus the protons.